Now, lecture is being recorded. Numerical exercises on preparation of solutions. I think we discussed what is meant by solution, and the learning objective of this exercise are explain the meaning of different kinds of solution. What are different kind of solution? Your normal solution, molar solution, and so on. And prepare the solutions of different strength for analytical purposes. These are learning objective. You can see small terms that frequently come across them. And in this case, you can see this is atom, the smallest unit of a matter that forms a chemical element. That is smallest unit of matter. Every solid, liquid, gas, and plasma is composed of neutral or ionized atoms. So you can see this plasma is kept outside solid, liquid, and gas. You need to know what is plasma. Atomic weight. This is relative atomic mass or weight is a dimensionless physical quantity, that is ratio of the average mass of atoms of a chemical element in given sample to the atomic mass constant. The atomic mass constant, symbol is Mu, is 1/12 of the masses of a carbon atom. Carbon 12 atom means how many times it is heavier than 1/12 of the mass of carbon. Before, people used to have hydrogen, but now they use this carbon, 1/12 of the mass of carbon. How many times it is heavier than that? That is your atomic weight. Chemical compound, composed of many identical molecules, composed of atoms from more than one element that held together by chemical bonds. That is called a chemical compound. Then element, the pure substance consisting only of atoms that all have the same number of protons in their atomic nuclei. Then it is your element. Equivalent weight, the mass of one equivalent, that is the mass of a given substance, which will combine with or displace a fixed quantity of another substance. The equivalent weight of an element is the mass which combines with or displaces 1.008 gram of hydrogen or 8 gram of oxygen or 35.5 grams of chlorine. These values correspond to the atomic weight divided by the usual valency. Somebody will explain in this sense. For oxygen as example, that is 16/2, that is 8 gram. Now suspension, a heterogeneous mixture of a fluid that has solid particles sufficiently large for sedimentation. The particles may be visible to the naked eye, usually must be larger than 1 micrometer and will eventually settle. Suspension. Ion, a particle, atom, or molecule. A particle, atom, or molecule with a net electrical charge is your ion. Matter, any substance that has mass and takes up space by having volume. You can remember this line. Matter, any substance that has mass and takes up space by having volume. Mixture, material made up of two or more different substances which are not chemically combined. In mixture, they are in physical contact, but they are not chemically combined. A mixture is the physical combination of two or more substances in which the identities are retained. Molecular weight, molecular mass or weight or molar mass. In short, molar is short for molecular. Molar mass are often used interchangeably. It is the mass of a given molecule measured in Daltons. dA, capital dA is the unit. Different molecules of the same compound may have different molecular masses like isotopes. Molecule, the electrically neutral group of two or more atoms. Two or more atoms can make a molecule held together by chemical bonds and lack electrical charge. They are neutral. Solute, it is in a homogeneous mixture, that is solution. So solution is a homogeneous mixture. The solute is a substance dissolved in another substance known as solvent. So it defines your mixture, it defines your solute, and also solvent. Concentration, measure of the amount of solute in a given amount of solution or solvent. That is your concentration. Solution, a homogeneous mix or mixture composed of two or more substances. The term aqueous solution is used when one of the solvent is water. The solvent, a substance that's dissolved a solute, resulting in a solution. A solvent is usually a liquid, but can also be a solid, a gas, or a supercritical fluid. Specific gravity, this is important, particularly for preparation of solutions in laboratory. Relative density or specific gravity is the ratio of the density. What is density? Mass of a unit volume. How much is the mass of weight of a volume, unit volume of a substance to the density of a given reference material. Many times the reference material is water. Specific gravity for liquids is nearly always measured with respect to water at its densest form, which is there at 4 degrees centigrade, or you can say precisely at 3.98 degrees centigrade. Water has highest density when maximum density. Then valency. The valency or valency, you can see the spelling. In one valency, it is E. Sometimes people also write Y. Of an element is the measure of its combining capacity with other atoms when it forms chemical compounds or molecules. In methane, carbon has a valency of 4. In ammonia, nitrogen has a valency of 3. So you can see element is one, but when it combines and makes different compounds, valency can change. Now we come to the main topic, that is stoichiometry. Stoichiometry. Try to understand this is what is stoichiometry. It describes the quantitative relationship among substances when they participate in chemical reactions. Reaction is stoichiometry. So this is a subject under which we study reactions of different chemical compounds. Study of another definition of stoichiometry is study of the quantitative relationship or ratios between two or more substances undergoing a chemical change or chemical reaction. Most often, stoichiometry calculations deal with the mass or volume of products and their reactants. Means whenever you are going to laboratory, most of the time you make solutions, and solutions you take a particular volume, and then you react one or two solutions, you mix them, and then you also see their reaction products. So these are actually part of the subject stoichiometry. Now in I'm sorry, I must admit someone. Now you see there are different ways to express the concentration of solution. So one way is based upon equivalent weight, or maybe based upon molecular weight, and many more things are there. So we start with the standard solution. So what is a standard solution? So solution of accurately known strength, means of concentration, is called standard solution. Means solution for which we know the strength. It contains a known weight of the reagent in a definite volume of solution, concentration being expressed usually in N, normal T. For a standard solution, concentration is expressed as N, is capital N, but italics. There are two kinds of standard solutions, primary standard solution and secondary standard solution. So in this case, we are already knowing that how much solute is dissolved in what volume of water or any other liquid or solvent. So let us see what is difference in primary standard solution and secondary standard solution. Primary standard solution is prepared when accurately weighing a chemically pure substance and then dissolve it in a designated volume of the liquid or water. The substance should not change its composition either during the weighing in solution during its preparation. Is primary standard solution you can prepare for the products or for the compounds which do not change their composition when you are weighing. Means they do not absorb water or give up water. They will remain as such, and you can accurately take the weight of this and mix it in known volume of the liquid or solvent, and then you can write down the concentration in normality with surety that it is having 2 normal or 3 normal or 0.1 normal strength. And this normality, one normal strength means you have dissolved 1 gram equivalent weight of a substance in a liter of water, in a liter of solution. So I think now you understand what is primary solution. You can primary standard solution. So if you see more about primary standard solution, it is one which can be prepared directly by weighing and with which other solution of approximate strength can be titrated and standardized. So this primary standard solution will be used to standardize other solution. And it can also be used to know the strength of any other solution. This primary standard solutions can be used to know the concentration or strength of other solution also by titration. Now see what is secondary solution of approximate strength or normality. So normality is also a kind of strength of a solution or concentration of the solution. Means how many times equivalent weights are dissolved in a liter of solution. So secondary solution, secondary standard solution is approximate secondary solution of secondary standard solution of approximate normality or strength can be prepared by dissolving the gram equivalent weight of the substance per liter of the solution. Means you need to dissolve the gram equivalent weight in water and make up the volume of the solution to 1 liter. Means that 1 liter will contain 1 gram equivalent of the substance, 1 liter solution. And then exact standardization is done with some primary standard solution. This primary standard solution can be used to know the strength of the this secondary standard solution. So, because many few substances or few compounds can be used, only few compounds can be used to make primary standard solution. But not all compounds or acids can be used to make the secondary standard solution. You need to go for titration, standardization of this secondary standard solution from primary standard solution. So actually, these are very simple things. And many agronomy students, they fear about these simple things and they make wrong solutions in the laboratory and their results cannot be correct if your solutions are wrongly prepared. Let us see more about primary normal solutions or primary standards. A reagent that is extremely pure and stable, it will not hydrate, it will not get water into it, and it has no water of hydration, and it has a high molecular weight. High molecular weight means you will need more quantities, then error will be less. So examples of primary standard for titration of acids you can prepare, like sodium carbonate can be used to prepare primary standard solutions. Molecular weight is 105.99 gram. Tris can also be used, tris hydroxymethyl aminomethane, tris or THAM, CH2OH thrice, OH whole thrice CnH2. Molecular weight is 121.14 gram per molecule. Example of primary standard solution for titration of bases. If you want to titrate the bases, potassium hydrogen phthalate, most common primary standard, KHP, potassium hydrogen phthalate, KHC8H4O4. Molecular weight is 204.23 gram. Potassium hydrogen iodate, KHIO3 twice. So molecular weight is 389.92. So you can prepare solution. For example, if you want to prepare potassium hydrogen phthalate, take 204.23 gram, dissolve in water and make up the volume to 1 liter. Likewise, you can prepare, I will show you how to prepare solutions. Now, secondary standard solution, a secondary standard is a standard that is prepared in the laboratory for a specific analysis. It is usually standardized against a primary standard. For knowing the exact concentration of secondary standard solution. Now, I'm giving you example of phthalate. Example is sodium carbonate, sodium oxalate, borax, succinic acid, and potassium hydrogen phthalate. These can be used to prepare primary standard solution. So suppose it is potassium hydrogen phthalate, C6H4COOKCOH. Equivalent weight is 204.1 gram. Is the equivalent weight, and then weigh accurately 20.41. Because if you are preparing n by 10 it means n into 1 by 10 or 0.1. 1 is divided by 10, then you can write it 0.1 normal, or you can also write it n by 10. So because you are going to prepare n by 10 solution, then weigh accurately 20.41. 204 divided by 10, then you get 20.41 gram of pure potassium hydrogen phthalate, and prepare 1 liter of its solution, n by 10. Means you mix it in water and make up the volume to 1 liter. This solution will be 1 by 10 normal potassium hydrogen phthalate solution, primary standard solution. This can be used to standardize an alkali like NaOH. Suppose you have prepared a solution of NaOH, which is in your view, you have done your best and you know that it is 1 by 10 NaOH, but here you cannot be sure. So you need to standardize it. You need to know the strength of this NaOH solution. So you can titrate it. Certain indicators are used. Indicator is phenolphthalein, and you see wherever there is change in color, that is the end point, and from N1, V1, N2, V2, you can work out the strength of the KOH or NaOH. Is it clear? Do you have any doubt in this? Anything you want to make clear? Anybody has any doubt? Are you listening to me or not?
Yes, sir.
You are listening?
Yes,
Yes,
sir.
Good, very good. So now you see if you have any question, any doubt, any clarification about it. Is it understood to you? I don't know whether you are getting it or not. Say yes or no. Well, if you got it, say yes so that I can move forward. But if you have any doubt, anything in your mind, you want, don't get shy in asking the things if you don't know them. Shruti, are you getting it?
Yes, sir.
Abhishek, is it all right? Should I move or you want to ask anything? Abhishek, are you there? Abhishek Patidar. Are you going to sleep?
Hello, hello.
Yeah. Did I disturb
Yes,
you?
there, sir. I want,
Okay, you got it.
sir.
All right.
There is a network issue, sir, in my house, sir.
Okay. So is it daily or is it occasional you get network issue?
Hello?
Is it daily you are
Sir?
facing
No,
occasional?
sir, no daily, no, sir, not
Okay.
daily, sir.
No. Okay. So we move forward. Now you see what should be the characteristics of the substances that can be used to make primary standard. Not every substance can be used to make the primary standard. Certain characteristics are to be there in the substance. Then only we can use it to make primary standard solution. First thing is that it should not change its composition. It should not degrade. It should not decompose. It should remain as such. Should not change its composition. It should remain the same chemical formula, either during weighing or in solution during its preparation. Here, SOL means solution. It must be easy to obtain, to purify, to dry, and to preserve in a pure state. Should not be hygroscopic or oxidized by air, nor affected by carbon dioxide. Means its weight should not change. Composition must remain unchanged during storage also, and should have a high equivalent weight so that the weighing errors may be negligible. It should be readily soluble under the conditions in which it is employed. So these are the characteristics, and certain chemicals or compounds qualify for it, and I have already given you the list. Now we go to the, you have seen standard solution, now you see normal solution. What is a normal solution? So they are frequently used in chemical analysis. You need to prepare solution of different substances, different acids. Solution containing 1 gram equivalent. See, remember it is solution. It is not the solvent. So solution containing 1 gram equivalent of the defined species or active reagent dissolved in 1 liter of solution is a normal solution. So normal solution is when you dissolve 1 gram equivalent weight of a substance in water, make up the volume to 1 liter, and that is your one normal solution. If you want to dilute it, you can dilute and you can further produce different strength solution. From this one normal solution, you can make half normal, 0.5 normal, n by 20, n by 10, n by 100, n by 1000, or it can be expressed as 0.1, 0.01, 0.001, 0.0001, like that. So you can dilute it. And I'll show you calculations how to dilute this solution to make further low concentration solutions. How you can make, we will see it. And equivalent weight expressed in grams is the gram equivalent weight. When you express equivalent weight in gram, it becomes your gram equivalent weight. Solution of approximate normal strength can be prepared by dissolving the gram equivalent weight of the substance, 1 liter of the solution, and then exact standardization is done with the help of primary standard solution. If it is required, you can standardize with the primary standard solution. Standardization means knowing the exact strength of the prepared solution. Now we go to the normal solution continues. If the number of gram equivalent is 1/10, 100, or 1 by 1000, then the solution is designated as n by 10. You can write decinormal, n by 100, or you can write it 0.01 normal. It is one and the same thing. You write n by 100, or you can write 0.01 n. That is centinormal. And if it is n by 1000 or 0.001 normal, then it is millinormal. It is called as millinormal solution. So overall normality is equal to number of grams of solute, in 1000 ml of solution. Or you can see actually number of gram equivalents of a solute in 1000 ml solution. That is exact. Suppose you take two times weight gram equivalent weight 2 times or 3 times or 4 times and make a solution of 1 liter, then it will be 2 normal, 3 normal, or 4 normal. How many times of the gram equivalent solute is there in 1 liter of solution? That also tests the strength. So 1 normal solution is not fixed. You can concentrate it, you can make 2 normal, 5 normal, 10 normal. Suppose you have sulfuric acid, and in sulfuric acid, it is written as 36 normal. What does it mean? What does it mean? If I say sulfuric acid has this 36 normal strength, what does it mean? Anybody? Anybody can tell me. Dhyan,
Sir, please repeat the question.
yeah, question is that suppose you got sulfuric acid and on the bottle it is written 36 normal. 36 normal, because right now I told you how to get 1 normal solution. And in that case, sulfuric acid bottle, it is written 36 normal. Then what does it mean? What is the difference in 1 normal and 36 normal solution?
Sir, 1 normal solution means there will be 49 ml of sulfuric acid.
Good.
If it is 36 normal, then it will multiply by 36.
Very good, super. So that is the meaning, simple meaning. It is not very rocket science, it is simple, because one normal means 1 gram equivalent is dissolved in a liter solution. And similarly, if you have 36, so that means 36 times gram equivalent is dissolved. And you said that for sulfuric acid, gram equivalent is 49 grams, something like that. Then 49 into 36, that will be the quantity of pure sulfuric acid in a liter of sulfuric acid bottle. Very good. Is it clear to other students also? What is meant by 36 normal or 5 normal? 5 normal means 5 times gram equivalent weight. 6 normal means 6 into gram equivalent weight. It will give you 6 normal. Is it clear to everybody? I think many of you might be knowing it, but those who do not know, there's no harm in learning it. Now you see, this is one more thing has come. Now you understand gram equivalent weight, how to make normal solution. And in this, you see the right side, sulfuric acid. This is picture I taken from bottle. And you see H2SO4 and FW. What is FW? Anybody? Dhyan, again, what is FW? Are you using mobile or you use laptop or computers for these lectures? Dhyan, mobile. That is why you are not able to see it, because your screen size is very small. So it is FW means formula weight. Formula weight. Yeah, 98.08, 06 or 08, whatever it is 98. That is why one of you very quickly said that it is 49 gram, because it has got, it is to be divided by 2 to get gram equivalent weight. So you got 49 gram in a liter of solution. That is your 1 normal solution. And then 49 into 36 times means this gram equivalent weight is dissolved 36 times in a liter of solution. Remember, in a liter of solution. But one more thing has come here. One more thing has come. Besides this molecular weight or formula weight, you get purity of the substance, 37%. You see, 37%, because most of the time, when you go to the laboratory, the normality of the solution or normality of the acid is not written on the bottle. Normality is normally not written on the bottle unless you buy it. So you do not know what is the normality of the solution. You take any bottle of acid, any acid in the laboratory. Normality is not given. What is given there? You will find molecular weight. You can see in this case hydrochloric acid. It is 37% pure. And molecular weight is there 36.46. Even they don't give you equivalent weight. They just give you molecular weight. Then you need to calculate equivalent weight. So here it is HCl. That means it is to be divided by 1. HIN is 1. Valency is 1. So you divide by 1. So you get same equivalent weight here, 36.46. But in case of sulfuric acid, you get 98 because there are two H2, H plus, H plus. So you divide it by 2 to get equivalent weight. So now question comes, how you can calculate the normality? How can you know the normality? Because suppose in your laboratory, if I ask you, when you go for titration of nitrogen, total nitrogen in soil or plant, it is worked out by Geldal method. I think you might be knowing. In Geldal method, you get 3 major steps. First is digestion of the sample. Then you go for distillation of ammonia. And ammonia is trapped in boric acid. And then you go for titration with sulfuric acid. Sulfuric acid is used as a titrant in nitrogen estimation. The concentration of sulfuric acid varies with the kind of material you have. Normally, you can have 0.01 normal, 0.05 normal, 0.001 normal. So these kind of solutions are required for titration. 0.001 normal solution. But just now I have told you that sulfuric acid, normally it is 36 normal solution. Normally the sulfuric acid bottle is of 36 normal, but you need to know exact normality. Don't trust what is written on the bottle. So from this 36 normal, you need to make 0.001 normal solution. You need to make, then how to do it, that we are going to learn. Because in your bottle here, see, suppose you want to prepare 0.01 normal solution of HCl, hydrochloric acid. So only 2 information are given here, 36%, 37% purity and molecular weight. And one more thing is also given here, which is not visible on this bottle, but on the right side bottle, you can find different parameters are given. So in this case, you can see the meets, the purity is, the assay as H2SO4 is 95.8%. On the right side, the purity of sulfuric acid is 95.8%. And then you see color, and one more thing you can see is specific gravity. Specific gravity is 1.84. So let me admit one more student. So you can see specific gravity. Specific gravity is 1.84. So what I mean to say, if you know the equivalent weight of any acid, any material, suppose here it is sulfuric acid or hydrochloric acid, you need to know equivalent weight that you can know from molecular weight. This is one. Number 2, you need to know purity. How much is the purity of sulfuric acid or purity of the material? It can be 95.8% in sulfuric acid. Sometimes it is 98%. And you see on the left side, HCl, it is just 37% pure. Means in this particular bottle, only 37% is hydrochloric acid. Rest is something else. So based upon specific gravity and purity and gram equivalent weight, you can calculate the strength of the solution. That is normality of the solution. Normality means how many times gram equivalent weight is dissolved in a liter of solution. How many times gram equivalent weight is dissolved in a liter of solution. That is your normality. If it is dissolved 5 times of the gram equivalent weight, then it is a 5 normal solution. And if you know the strength of the solution, that it is 5 normal solution, then from this solution, you can easily make solution of lower strength, say 0.001 normal. I will show you. But for the time being, I make a break and we will meet at 4 p.m. We will meet at 4 p.m. In the meantime, I will send you the correct and if you want to have a break for tea. So I will have some tea during, or you can also have tea, and we meet at 4 o'clock. Or yeah, we can meet at 4 o'clock. Fine? Is it fine? I will send you links by email.
Fine, sir.
And we
Yes,
can
sir.
meet at 4.
Okay, sir.
Bye.
Yes, sir.
So now, based upon concentration of purity, equivalent gram equivalent weight, and specific gravity, we will calculate the or compute the strength of a solution, strength or normality of a solution. So I make you understand with one example. So given the specific gravity 1.84, this is the specific gravity, and purity is 96%. So this is very hypothetical example. Prepare a 1 normal solution of sulfuric acid. Also calculate the amount of sulfuric acid needed to make 1 liter of 7 normal solution. Equivalent weight of sulfuric acid is 49. Many of you know it. So here you are given a specific gravity of 1.84. It can be 1.83. It can be any value depending upon the acid or material. So what does it mean specific gravity 1.84? What does it mean? Can anybody tell me what is meant by 1.84 specific gravity? Satyam. Satyam, are you there?
Yes, sir.
Yeah, what is specific, what is meant by 1.84? And it is unitless value, you see, specific gravity is unitless value here. Specific gravity 1.8. So what does it mean actually? Anybody?
The equal volume of water as compared to water weight, it is 1.84 times of fire.
Okay, that is also there. But if we see the meaning here, 1.84 means here it is the weight of sulfuric acid in a unit volume. Suppose you get 1.84 gram per cubic centimeter. If you have volume in cubic centimeter, then weight will be in gram. So that is the meaning. If it is liter, 1 liter, what is the volume? Okay, 1.84 means 1840 gram per liter of water, per liter of this solution of sulfuric acid. So actually what is there? The bottle which is available in the laboratory is a solution where you have some quantity of sulfuric acid dissolved. And if you see the specific gravity of this solution, which is having impurities, because it is 96% pure and 4% you have impurities. So overall, the specific gravity of the material in this is 1.84. If you take 1 cubic centimeter of volume of sulfuric acid, its weight is 1.24 gram. If you take 1,000 cubic centimeter, 1,000 cubic centimeter, 10, 10, 10, then it will have 1 liter, I think, 1 liter. 1 liter will have 1840 gram of sulfuric acid. So given the specific gravity 1.84, purity 96%, prepare a one normal solution. You need to prepare one normal solution. That means first we should know the normality of this solution. Also calculate the amount of sulfuric acid needed to make 1 liter of 7 normal solutions. We will learn this. Specific gravity is needed to calculate the strength of sulfuric acid. 1 ml sulfuric acid H2SO4 has 1.84 gram weight. That is also meaning 1 cubic centimeter means the weight is 1 ml. Sorry, volume is 1 ml. So 1 ml solution of H2SO4 has 1.84 gram of weight. 1000 ml, that is 1 liter. 1 liter will have 1.84 into 1000 gram is equal to 1840 gram. So is it clear or not? I assume you are not responding. I assume that you know it. So purity, now we need to see purity. We know the weight. In 1 liter, weight of sulfuric acid is 1840 gram. Because this is not pure, so we need to have purity of sulfuric acid, 96% purity. That means this 1840 into 96 by 100. That means 1766.4 gram pure sulfuric acid is there. So in 1 liter, out of 1840 gram, it is 1766.4 gram pure sulfuric acid. So this is the quantity, exact quantity of sulfuric acid in 1 liter. Now, you need to calculate the normality. See the right side, the brown square. Normality formula you need to remember. Weight of the pure acid divided per liter. In 1 liter, how much is the weight? And divided by equivalent weight. So denominator is equivalent weight. Numerator is weight of sulfuric acid in 1 liter divided by equivalent weight. Means how many equivalents are there. You need to calculate it. So you can do it other way around, other way also. So from this you can calculate very easily. Normality is equal to weight per liter. Weight is your 1766.4 gram divided by 49. Divided by 49 is the equivalent weight. So you will get the result, and result will be 36 here. 36. So if you do not want to use this formula, N is equal to weight per liter divided by equivalent weight. If you do not want to use this formula, you can calculate in this fashion also, like if 49 gram pure sulfuric acid is in 1 liter, if 1 liter solution of sulfuric acid contain 40 gram pure sulfuric acid, then its normality will be 1 normal. If 1 gram pure sulfuric acid in 1 liter, then 1 by 49 normal. This will be the normality. If it is 1766.4 gram pure sulfuric acid in 1 liter, then normality will be 1766.4 divided by 49 is equal to 36 normal. So strength is 36 normal. If you do not want to do calculation in this way, you can straightway put the value formula N is equal to weight per liter divided by equivalent weight. Now you know exactly the strength of this solution. It is 36 normal. That means pure sulfuric acid, that is 49 gram, is dissolved 36 times in 1 liter. So that is its strength. You can call it 36 normal. Now you know that this solution or this bottle has 36 normality of the sulfuric acid. Then from this, you can prepare solution of any strength, but less than 36 normality. You can prepare any solution because it is maximum strength is 36 normal. So from this, you can prepare 35 normal, 30 normal, 10 normal, 1 normal, 0.1 normal, any solution. By simply using this formula, you can remember N1 V1 is equal to N2 V2. So here you can say normality of the acid and volume of the acid. How much volume? V1 is how much volume will be required to prepare on the right side of the equal sign N2 V2. N2 is normality is 1 because you want to prepare one normal solution. You want to prepare one normal solution, then put here 1. And how much solution you want? You want 1 liter, you want 2 liter, you want 5 liter. According to that, you put the value in milliliter, ml. Suppose you want 1 liter, then you write 1000. If you want 2000, 2 liter, you write like this. And then you can calculate the V1. V1 is equal to 1000 divided by 36 is equal to 27.74 ml. So it means that you can take 27.74 ml of this 36 normal solution, mix it in water and make up the volume to 1 liter. Then you will get one normal 1 liter solution. Suppose you want to prepare 7 normal 1 liter solution. So you know the strength 36, volume you don't know V1, and you want 7 normal, so 7, and you want 1 liter. So 1000 ml, you get V1 194.44. Take this much quantity of acid from the bottle, which is 36 normal, and mix in water and make up the volume to 1 liter. Make up the volume to 1 liter, then you will have 7 normal solution. Any doubt, any problem, I give you 1 minute time to ask any question. If within 1 minute you are not asking, that means you know it. So this is not very tough thing, very simple thing. But most of the time I have seen in the laboratory PG lab that most of the students do mistake in preparing the solution. So, okay, I believe that you know. And if you know, then you please do it. This is the numerical, this is the exercise. You can do it now. So please do it. This is the example and you tell me the answer. You have time to do it now. So given the purity 39% and specific gravity 1.19, calculate the amount of HCl to prepare a 1 normal solution. Also calculate the amount of HCl required to prepare 8 normal 5 liter HCl solution. Equivalent weight of HCl is 36.5. So please do it now. And once finished, you inform me.
Sir, sir,
Yeah.
78.67 ml required for one normal solution of HCl.
Okay. I will check the answer. I will check the answer. Anybody else? So these numericals are very, very important, and many of you are in MSc, and these kind of numericals for those who are interested in PhD program in agronomy. So such kind of numericals usually come in your exam. Numericals related to chemistry, simple chemistry, or numericals related to pH, soil pH. Dr. Shive might have taken a class on pH. Has he taken class on soil pH? Soil pH practical class?
No, sir.
Not yet. Okay. So in pH also you got variety of numericals are there. The lime requirement calculation, gypsum requirement calculation, and some are related to what I am teaching today, and there may be some other variety of numericals also. So, and also in your interviews also, sometimes people ask questions like, if the hydrogen ion concentration of a solution is 0.001, what will be the pH? Some questions like this are also asked. Can you tell me the pH if your hydrogen ion concentration is 0.001?
Okay, sir.
Good. Very good. So this is very simple, but if I don't know, it will look very tough to me. So now you see the answer of this problem. My purpose was to make you practice, to make you understand. That is why I asked. I'm not taking your test. So now you see how we can do it. One normal solution needs 36.5 gram per liter pure sulfuric acid. This is required. Specific gravity is 1.19. That means 1 ml, the weight of 1 ml volume of this acid is 1.19 gram. That means 1000 ml contains 1190 gram HCl. 1 liter. 1 liter contains 1190 gram of HCl. Purity is 39%. So you get 39% of it. So you get 464.1 gram of pure HCl. Now you can simply calculate by this relationship, normality is equal to weight per liter by equivalent weight. So weight is 464.1 and divided by the equivalent weight, that is 36.5. And you get the answer 12.7. I think your answer was right. 12.7. And now you want to prepare solution of 1 normality and 1 liter. So N1, V1, N2, V2. So normality now you have 12.7. It is calculated by you. volume you don't know, to make one normal 1 liter solution. So now V1 is equal to 78.7. So you have normality 12.7. Take 78.7 ml of 12.7 normality solution in bottle, and then you mix it in water, make up the volume to 1 liter. This will be your one normal 1 liter solution. Now, same way, if you are asked, prepare 8 normal 5 liter solution. So you can do in the same way. 12.7 B1 is equal to, in place of 1 normal, you can put 8 normal. In place of 1 liter, you can put 5 liter or 5,000 ml. So you get the volume 3,149.6 ml. Take this much of HCl and make up the volume to 5 liter. Make up the volume to 5 liter. So that will be your 5 liter 8 normal solution. Any question, any problem in this? You can ask. Now, these examples I am giving you as homework. Shortly, I will share this PowerPoint presentation you can get from me. I will send you. And then you can do this numerical. You are required to make a practical record in Word file. In Word file, you can make a practical record and write about this practical. And if you do not have, did Dr. Shiva give you a practical PDF of the practical manual? One manual is there, manual of soil fertility. Did you get the PDF file of that manual?
No, sir.
Not yet. Okay. I will discuss with him and we will send you PDF file of the manual. Practical manual of soil fertility means how you do it. So in that booklet or bulletin or whatever you call manual, we have one chapter on this calculations. We have inserted that chapter in the manual. So you can make use of that chapter also for your further preparation. Or I can send you some books, 1 or 2 books, where such numericals are there. Here I am just giving you some hint, just exposing you to the topic. Rest is in your hand. If you are interested, you can learn. If you are not interested, nobody is forcing you to learn. But I can facilitate you in providing certain books which have numericals. Variety of numericals are there. And numericals which are concerned to us, you can solve those numericals. Now, prepare one normal solution of acetic acid on the basis of following information. So this question can come in any form. Equivalent weight is 60 for this acetic acid. Purity is 99%. Its specific gravity is 1.06. And then you need to prepare 6 normal 7 liter solution. Simple. Prepare one normal solution of ammonium hydroxide on the basis of following information: purity 28.3%, specific gravity 0.91, and equivalent weight is 35.05. So you can do these numericals, type them, do it in Word file, and finally you can convert it into PDF so that your practical record will be there. And that can be used by you. Now, one more numerical, you can do it now if you like. Calculate the normality of a solution containing 1.7 gram of silver nitrate per 100 ml of the solution. Equivalent weight is 170. Equivalent weight of silver nitrate AgNO3 is 170. So calculate the normality of a solution containing 1.7 gram of silver nitrate per 100 ml. Means 100 ml contains your 1.7 gram. Then calculate the normality of a solution. Can you do it now?
Sir, 0.1.
Very good.
Yes,
So
sir,
fast.
0.1.
So fast. I'm very happy. I think you are just छुपा रुस्तम हो, तुम लोग मुझे बता नहीं रहे कि सर तो फिर अगर इतना अच्छा जानते हो, really I am happy about you. So you can see it can be done simply by this. So solution is normality means number of gram equivalents per liter. How many times gram equivalents are there in 1 liter solution? So number of equivalents you can calculate. Weight in gram, if you know the weight in gram, and divided by equivalent weight. So number of equivalents of silver nitrate. This is lengthy procedure for a person like me who experience the thing. So number of gram equivalents of silver nitrate 1.7 divided by equivalent weight. It is 170. So you get 0.01. Normality is cut to 0.01 divided by, because it was 100 ml, so you get 0.1 normal. Other ways, other words, rather simplest way is 170 gram of silver nitrate dissolved in 1000 ml solution will give you 1 normal. If 1 gram is dissolved, it will give you 1 by 170 normal. If 17 gram is dissolved, then it will give you 0.1 normal. So this is how we can calculate it. So this is also your homework. Calculate the weight of HCl in 2 liter of 0.1 normal HCl. So you can do it like this. 1 normal 1 liter HCl contains 36.5 gram HCl. 0.1 will contain 36 by 10, 3.65. And 0.1 normal, now it is 2 liters, so double it. It is 7.3 gram. Very simple. Now, after normal solution, we come to molar solution. So what is molar solution? Solution in which 1 gram molecular weight of the solute or is dissolved in 1 liter solution. So here, instead of gram equivalent weight, it is gram molecular weight or molar weight. It is denoted by capital M italic. 1 molar solution of oxalic acid, for example, C2H2O4, 2H2O contains 2 carbon, so 2 into 12 plus 2 hydrogen, 2 into 1, plus 4 oxygen, 4 into 16, plus 2 H2, you get H2O, you get 2 into 18. So it comes out to be 126 gram per liter. I think you know this weight of these and you can calculate the molecular weight. Molarity is equal to number of grams of solute present in 1000 ml of the solution. 1 molar solution contains 1 molecular or 1 mole or 1 molecular weight. Mole means molecular weight in grams of a substance in each liter of the solution. Molar method of expressing concentration is useful due to the fact that equal volume of equimolar solution contain equal number of molecules. So this is about molar solution. Calculate the molarity of a 100 ml solution containing 0.32 gram of NaOH. Now you know how much weight is dissolved in 100 ml, this much quantity of NaOH there. Then you can calculate the molarity of this solution. So molarity is equal to number of moles per liter. Moles means molecular weights. So number of moles of molecular weight is equal to weight in gram, how much is the weight, and then molecular weight. So 0.32 was the weight of the NaOH divided by 40. You know NaOH molecular weight is 40. And then it is 0.008. So molarity is equal to 0.008 divided by 0.1 because it was in 100. It was in 100 ml. So it comes out to be 0.08. Or you can see other way also, this yellow color. 1000 ml solution will contain 3.2 gram of NaOH because 100 ml, it is 100 ml. If it is 1000 ml, then you will have 3.2 gram of NaOH. So molarity you can calculate. Molarity is equal to weight in gram divided by molecular weight. So you get 0.08. This is more simple. calculation about molar solution. Now calculate the weight of NaOH in 5 liters of 0.65 molar NaOH solution. Please try it, do it. Calculate the weight of NaOH in 5 liters of 0.65 molar NaOH solution.
One 130 gram.
Good. So he's correct. Calculate the weight of NaOH in 5 liter of 0.05 molar NaOH solution. So 1 liter of 1 molar NaOH solution contains 40 gram. This is very simple. You know it. If 1 gram molecular weight in gram is dissolved in a liter of solution, then it is 1 molar. So 5 liter, if you want 5 liter, you multiply 40 by 5, you get 200 gram NaOH. Then 5 liter of 0.65 instead of 1 molar. Now you have 0.65 molar, and you multiply it by 0.65, you get 130 gram. So this is done. So now our time is going to be over. So we go to the next link, and then I will try to finish. We go to the next link. Now we stop sharing here. And this is very unfortunate part that only 12 students are there, or 11, I think, or 10. Now there are only 10 students. I will inform the course leader about your attendance. Welcome back. Now this is example, your homework again. How many grams per milliliter of NaCl are contained in 0.250 molar solution? So you can do it. Next is your how many grams of sodium sulfate should be weighed out to prepare 500 ml of 0.1 molar solution. These are numericals. You can try. Maybe very shortly I will send you this PowerPoint so that you can do this exercise. Now some difficult numerical, bit difficult. Calculate the concentration of potassium ion in grams per liter after mixing 100 ml of 0.25 molar KCl and 200 ml of 0.1 molar potassium sulfate. So this numerical is done here. You can understand it. It is very simply explained. And if you fail to understand any point anywhere, you can discuss with me. So this is the solution for the last numerical. Please go through it and hope you will be able to understand it. Next is milliequivalent, as I was discussing about the importance of milliequivalent. So milliequivalent weight in gram, MEQ. Sometimes it is written as MEQ and sometimes it is M.E, milliequivalent. And now in American fashion, it is just written as ME, me. So milliequivalent weight in gram of a substance is the equivalent weight in gram divided by 1000. That is milliequivalent. It is equivalent to 1 ml of 1 normal solution. See any solution, if it is 1 normal and 1 ml, resume share. So it is equivalent to 1 ml of 1 normal solution. Means any solution, if you have 1 ml and multiply with 1 ml of 1 normal solution, you know the normality and you know the volume. You can calculate the milliequivalents. So 1 ml, 1 normal is 1 milliequivalent. it is equal to 1 milliequivalent, because milliequivalent is equal to normality into volume. So normality is 1 here. Volume is also 1 ml. So your equivalent is 1. Suppose you have two normal solution and you have consumed 2 ml or you have consumed 3 ml in titration. So 2 into 3, 6 milliequivalent are there. 6 milliequivalent of a substance was there. You estimate the nitrogen by general method, simple method. And there are 3 steps, as I told you before: digestion, distillation, and titration. You digest the organic nitrogen and bring it into the solution, bring it into the mineral form, or finally you make ammonium sulfate. Then this ammonium sulfate is distilled and your ammonia is liberated, and that ammonia is trapped or absorbed in sulfuric acid. Oh, sorry, boric acid, 4% boric acid with mixed indicator. Then you go for titration with sulfuric acid. You can have 0.01, 0.1, 0.5, or 0.005, any concentration of sulfuric acid in the burette. It is called as a titrant. Now this titrant you have consumed, suppose 10 ml or say 8 ml. 8 ml of sulfuric acid is consumed, and in the blank you have consumed say 0.5 ml. So overall your 7.5 ml of sulfuric acid is consumed. Suppose its normality was 0.1. Suppose normality was 0.1. So 0.1 into 7.5. So this much equivalent of nitrogen is there. This much equivalent of nitrogen is there in the sample. And then you can multiply it with equivalent weight and you will get the value in milligram. So you see now the volume has been converted into milligram weight. So this is the utility of milliequivalents. I will explain you further. So it is a unit which is common to both volumes and weights, making it possible to convert the volume of a solution to its equivalent weight and the weight of a substance to its equivalent volume of solution. It can go either. See here, I was giving you example of nitrogen. Number of milliequivalents or milliequivalent is equal to volume of solution into normality, N1V1 or N into V. So milliequivalents is equal to volume into normality. Now milligram, now you have got the milliequivalent, you know the strength of the solution you are using in titration. Suppose it was sulfuric acid and its normality was 0.05 and volume, you know how much it is consumed. You multiply both, you will get the milliequivalents of the substance. Then you want this milliequivalent in milligram. So milliequivalent per liter, you multiply it by equivalent weight. If you multiply by equivalent weight, you will get milligrams. Now you see it has come in weight. The material has come in weight from volume. Now you want it in gram because initially you take soil sample in grams, 0.1 gram, 0.5 gram, 0.6 gram. In starting you take sample in gram. So substance that is there and you want in percentage, then you need to convert it into gram, milligram per 1000, because you got the milligram. This milligram can be converted into gram if you divide it by 1000. So milligram divided by 1000, you get in gram. And you already know that how much is 1 ppm. 1 ppm, if a substance is there, say 1 milligram in a liter of solution, then it is 1 ppm. If it is 100 ppm, that means 100 milligram of the substance in 1 liter solution. So percentage is equal to ppm divided by 10,000. If you have data or concentration in ppm, you can convert to percentage if you divide it by 10,000. Or ppm can be or percentage can be multiplied by 10,000 to get value in ppm. Multiply the percentage with 10,000, you will get data in ppm. ppm into 2 multiply by 2, you get pounds per acre. And pounds per acre is multiplied by 1.12. You get kilogram per hectare. Or directly you can multiply ppm into 2.24. You can convert it into kilograms per hectare. Weight of 1 hectare 0 to 15 centimeter soil is 2.2 into 10 to the power 6 kg per hectare. Or you can write it as 2.2 million kg per hectare. 1 million is equal to 10 to the power 6. Now, if you could not understand anything from this, or the things which are not clear to you, it is time to ask.
Sir, please clarify milligram equal milliequivalent per liter multiplied by equivalent weight.
Yeah. So actually it is your, now you have got the data in milliequivalents. Now you have results in milliequivalent of a substance. So therefore, if you multiply the milliequivalents per liter with its equivalent weight, then you get the substance in milligram. If you want weight of the substance, then you need to multiply milliequivalent per liter of the substance by equivalent weight to get the value in milligram. This is the kind of relationship that has been developed by people who worked initially in chemistry. So this is a fact. This is a fact that milliequivalents multiplied by equivalent weight, you get value in milligram. Is it fine or not? This is the relationship. This is the relationship, or this is the way to get milligram. Milliequivalents per liter, you know how we have worked it out. If you multiply it by equivalent weight, you will get the value in milligram. This is a fact. And I know only this one, that to get milligram, you multiply milliequivalent by equivalent weight. Derivation and those things are not clear to me, but I will try to find it out. I will try to learn it from some source and come back to it. So any other point?
That by 2 equal pound per acre. How is it?
Pardon?
ppm multiplied by 2 equal pound per acre.
Pound per acre.
How it is?
So this is also kind of relationship, which is already kind of formula, you say. How it has come, that is not clear to me, but it is a fact that suppose you have taken a soil sample. Soil sample is taken from, this is actually old unit, but now you can see it is kilogram per hectare. So what is there that you need to understand, just let the time come when I teach you nitrogen and carbon estimation. That time I will give you more clarity about it. And for the time being, you can remember that you take soil samples. And when you report the results, those results are reported in kilogram per hectare. Suppose you are going to estimate, say, potassium in the soil. Potassium estimation is there, and you have found the results. And then you want to convert it into kilogram per hectare. Because in case of potassium estimation or phosphorus estimation, you get results in ppm or milligram per kg soil. And this is to be converted on hectare basis. So you need soil weight. You need weight of 1 hectare soil. Soil depth is 0 to 15 centimeter. And this 0 to 15 centimeter. So because you are taking a sample in gram, say 1 gram sample, 0.5 gram sample, say you have taken 0.5 gram sample. In 0.5 gram sample, this much of potassium was there. But that was in ppm actually. When you estimate potassium, you get results in ppm. So that ppm can be directly multiplied. Instead of pound per acre, you can multiply that ppm directly by 2.24. And you will get results in kilogram per hectare. So you need not to bother much about how this 2.24 has come. But it is important to know, of course, it is important to know But for the time being, you can see that it is a conversion factor. It is a conversion factor. If you want to convert ppm into pounds per acre or kg per hectare, you need to multiply these factors. I don't know whether I was able to answer your question.
Okay, sir.
So this is the actually problem with many of you, that you do not have a working lab. You cannot see lab. If you do it, then you will understand that which element or which nutrient element is estimated by which procedure and how it is done, and in what form you get the result. So actually, when we conduct practical physically in physical presence, then the understanding will becomes much better, because we stand beside you when you do the practical. So every point is made clear. But this is your online anyway. See some more relations. Common units for expressing trace concentration means sometimes now these days people are talking about ppm, ppb, and more new units are coming, microliters, nanoliters, picoliters, and so on. So variety of units are coming. Here, my purpose is to expose you to learn different units. So you can see unit abbreviations and weight by weight, weight by volume, and volume by volume. So see their relationship also. Parts per million, 1 ppm. 1 ppm is equal to 10 to the power minus 4 percentage also. So that is why you can divide ppm by 10,000 and you get percentage. So ppm is the abbreviation for parts per million. And if you are reporting weight by weight basis, any substance, then milligram per kg. Milligram per kg is the unit. But these days now, if you want, you can write it microgram per gram. Instead of, if your substance is very small, concentration, very small concentration, then instead of milligram per kg, you can go for microgram per gram. Suppose a substance was there, say 10 milligram per kg, then it will be 10 microgram per gram. So that is how they are almost equivalent. Like, you know, okay, I don't go into that much, but you can remember the figure will remain same. The figure will remain same, only the unit will change. Suppose you have 20 milligram per kg of substance, then you can also write it as 20 microgram per gram. These units have been made in equivalent way. Now, if ppm is there and it is in solution, so that was for solid things. Now you have weight by volume. Something is dissolved, some solute is dissolved, which was solid. Then you can report it milligram per liter instead of milligram per kg, milligram per liter. And then same way, you can write, suppose it was 15 milligram per liter, then you can write 15 microgram per ml. So they are equivalent units. Then volume by volume. So volume by volume for ppm, you can write microliter per liter. Microliter per liter. This is volume by volume. And then its equivalent is nanoliter per ml. Nanoliter per, it also have same. If it is 10 microliter per liter, then it will be 10 nanoliter per ml. Then comes parts per billion. It's still a smaller unit. So 1 ppm, 1 ppb is equal to 10 to the power minus 7% or 10 to the power minus 3 ppm. They are very, very important units. And sometimes you get numericals conversion of units. So written by ppb, it is instead of milligram per kg, it means microgram per kg, which is equivalent to nanogram per gram. Nanogram per gram. 10 microgram per kg is equal to 10 nanogram per gram. Then weight by volume, microgram per liter and nanogram per ml. And volume by volume, nanoliter per liter, picoliter per ml. So you can see here, PL is picoliter, 10 to the power minus 12 liter. Sometimes these concentrations are written as ppmv. Sometimes you will find This is for volume basis, or ppb, pp, bv, okay, pp billion, v volume, and so on, indicating by volume. Ng is your nanogram. 1 nanogram per gram is equal to 0.001 milligram per kg, or 1 mg per kg is equal to 1000 nano. So you can, this way you can have some understanding. It is up to you whether you find them useful or not. If you find them useful, you can remember. Now, one or two small numericals are there. Like you do numericals in soil fertility course, even in your BSc AG, you must have learned about if a numerical is given that if a farmer wants to supply 80 kg nitrogen to mustard crop and say 30 kg phosphorus, and these are the fertilizers, say DAP is the fertilizer, urea is also there, then what is the quantity of fertilizer? And you use to calculate. Similarly, for ppm concentration, preparation of solutions in ppm, you can follow the same formula here. So prepare 1 liter 1000 ppm phosphorus solution from KS2PO4. Very frequently prepared by students. They prepare a stock solution, and then from this stock solution, they can prepare working solutions. So now your problem is that you need to prepare 1 liter 100 ppm phosphorus solution. It is not solution of KS2PO4. It is solution of phosphorus. So the molecular weight of KS2PO4, you can work it out, 136.1 gram. Now calculate the amount of KS2PO4 to prepare 1 liter 100 ppm solution. So it can be done in this way. 100 ppm solution needs 100 milligram P. Now, first of all, you need to calculate the amount of phosphorus that will be required to prepare 100 ppm solution. So 100 ppm P solution needs 100 milligram phosphorus. It is known to us. Now 136.1 milligram KS2 contains 31 milligram. These two things are given to us, or we can know it. Now you can see 31 milligram phosphorus is available in 136.1 milligram KS2. You have seen this phosphorus. 1 milligram P is available in 136 by 31. So 100 milligram, because this is required to prepare 100 ppm P solution. So 100 ppm P is available from, you multiply 136 by 100 by 1000. So you get 0.4390. Anybody could not follow it? So this is same way you used to calculate urea, if you know that. Thing is that we should know that if we want to prepare 100 ppm 1 liter, then 100 milligram P will be required. And if you want 500 ppm, then you will need 500 milligram. If you increase the quantity of the solution, make it 2 liter, then it will be 200 milligram. Likewise, we should know exact quantity of phosphorus that is required to prepare the solution, and then how much fertilizer or how much compound will be required to get the required phosphorus. So there are two simple steps, and you can work it out. Is it okay? This you can do it. Now next is prepare a 2 liter 1000 ppm K solution from KCl. So this is a problem. So molecular weight of KCl 74.55. So you can know 1000 ppm means you need 2000 milligrams. 2000 milligram for prepare a 2 liter 1000 ppm. So 2000 milligram, because it is 2 liter. So you will require 2000 milligram of K. So then how much KCl can supply you? 2000 milligram of K. So you can work it out. You know the molecular weight. You also know the weight of K. It is 39. So 39 is available from 74.55. Therefore, 2000 ppm or milligram is available from this. Now, prepare a 2 liter of K. This is very simple. You can do it. This is your homework. A 2.6 gram sample of plant tissue was analyzed and found to contain 3.6 microgram zinc. What is the concentration of zinc in the plant in ppm or in ppb? So you know the table. From the table, you can convert it. This is the last slide. You can see here how it can be converted. A 2.6 gram sample of plant tissue was analyzed and found to contain 3.6 microgram zinc. What is the concentration of zinc in plant? ppm, ppb. So you know the weight of the sample was 2.6. In this 2.6 gram, 3.6 microgram zinc was there. So 1 gram will contain 3.6 microgram by 2.6 gram zinc. So it is calculated as 1.384 microgram per gram zinc. So you can write it in ppm as 1.384 ppm zinc. So now in percentage, if you want to calculate ppm into 10 to the power minus 4, I already know it. So 1.384 into 10 to the power minus 4, you get answer in percentage. 1000 gram 1 kg sample contains 1384 microgram. So this is gone for 1000 gram of 1 kg. And it is 1384 nanogram per gram parcel. So it is like this. You can get these kind of numericals, and this ends this lecture. Now, if you have anything in your mind, if you want to ask any last questions, you are welcome. And so is it all right to end this lecture now? We had some problem today in running the class, but at last we succeeded in doing it. But I am really worried that very few students are attending the class.